All right, so my name is Preston Black, and this is observation 4 for National University. I have a small group of my wonderful learners, and we'll be going over linear functions and the parts of the equation y equals mx plus b. Okay, so we've been talking about linear functions, recognizing them in graphs, recognizing them in tables, and understanding if they are linear or nonlinear. And then how do they fall into the equation y equals mx plus b? So before we get started on your guys' Jamboards, you guys have 4 words, right? So you have slope, initial value, y-intercept, and rate of change. Okay? What I want you to do before we start, okay, is go ahead and label slope as if it was in the equation y equals mx plus b. What does slope represent in y equals mx plus b? Okay, and you're going to do that for all 4. So I'm going to give you 2 minutes. Okay, I'm going to set a timer, and we'll come back, we'll share out our answers, and then we will go ahead and move on into the lesson. Okay, so these are our vocabulary words that we really need to know in order to work on the problems that we're going to be working on. So remember, Rihanna 1, Philip 2, Melanie 3, and Jordan 4. So the Jamboard is something that I've been using in my classroom for about a month or so, and it really gives the learners a way to share their learning in real time without having to come off of mute and kind of share out, because at least in our district, I found it very hard to have the learners not lag. So whenever they're speaking, it's very hard to make out what they are saying because of internet issues. So this is a way that we've used, that I incorporate in my math lessons and in my ELA history lessons. So as you can see, they've already labeled which vocabulary word goes with y equals mx plus b. So let's go look at the other one. Still working on it, still work good. And so they have another minute. But let's see, I have one learner who's not supposed to be here, who isn't going to their breakout room, so don't worry about them. All right, back to the lesson. All right, very good, Rihanna and Philip. Jordan and Melanie, I see you are almost there. Good, and we all got them correctly, right? So whenever we are looking at the equation, y equals mx plus b, right, we are identifying that if we see a word problem, right, we know if it's referring to the slope, that's going to be the m. If we refer to the initial value, that's going to be the b, right? If we look at rate of change, that is m. If we look at y-intercept, that is b, right? You guys did a very good job of being able to identify which parts of the equation, right, fit our vocabulary words. Okay, so now also on the Jamboard, okay, you have an equation. In the chat box, what is the equation that you see on your Jamboard? Tell me in the chat. What is the equation? What is the equation? Good. Y equals 1/2 x plus 25. Good. All right. So what I want you to do now is off to the side, find another part on your Jamboard away from your partners, okay? And I want you to go ahead and type out the slope in the problem, the initial value in the problem, the y-intercept in the problem, and the rate of change. Or actually just go ahead and put it in the text boxes that you already have. Just put it right next to it. So right next to slope, you'll put what is the slope of the equation. You get what I'm saying? Okay, go ahead. I'll give you guys 2 minutes to do this. So then being able to identify what parts substitute is something that they do a very good job of until there's a word problem. So one of the things that we've really been starting to work on with linear functions and the different parts is looking at word problems and figuring out what goes into what words exactly, what tells are we trying to see in a word problem that is going to give us the information that we need to throw into the equation. Good. So as you can see, they're putting slope, which is 1/2, which it is, right, in this equation. The initial value is 25, good. The y-intercept is 25, good. And the rate of change is 1/2. So once they were able to understand that the rate of change and slope is talking about the same thing, they were able to grasp the information a lot quicker. Some of my learners were having a tough time with understanding that both represented the same thing. Good. Good, 30 more seconds. All right, so they all have the correct answers. Good. All right, very good job, everybody. You were able to identify the correct slope, y-intercept, initial value, and rate of change for the equation that was given. Very good job labeling. Give yourself a round of applause. Give yourself a pat on the back. If you can reach it, pat on the back. There you go. Good. Okay, now if you could please go ahead and turn to page 3. Where is it? Oh no, I have too many tabs open. There we go. 361. 361 in your math book. 361. Whenever you have the page, go and hold up your book for me so I can see it. Okay, Jordan. All right, Melanie, thank you. Rihanna, thank you. Philip, thank you. Okay, and you should see a problem at the top with a nice piece of pizza or a nice few pieces of pizza. Give me a thumbs up. Do you guys see that? See the picture? Does it make you guys hungry a little bit? Pizza does sound good. All right. So I'm going to share my screen real fast. Okay, what I want you to do is make sure you have your whiteboards next to you so that you can use them for this problem. Hold up your markers, whiteboards. Let me see them. Boom. Thank you guys for being so great. Magnificent. All right, so let's go ahead and look at the problem that is on the screen. All right, so we are looking here at, we see a graph. We see some equations here. And now let's go ahead and read the problem. So a customer can use the menu above to call in a pizza order. He or she chooses a size and then adds toppings. The graphs and equations model the prices of the two sizes of pizza. So where on this problem are the two sizes of pizza? Where are we able to locate that at? In the graph, or in the chat box, tell me, where is the pizza price and the topping price located on the page? Where do you see it? It's under the pizza, right? It's okay. Some of us, it's almost Friday. I understand if you think, sometimes you may think your left is your right and your right is your left. No judgment zone here, okay? So we see here that a small pie costs $8. Not in California. We don't really call pizzas pies in California. But if you go to the East Coast, right, they don't really call them pizzas, they call them pies, right? So here we see a small pie is $8, or a small pizza, and a large pie is $12, right? So we know that how much more is the large pizza than the small pizza? How much more in dollars is the large pizza than the small pizza? $4, right? It's $4. 12 minus 8 equals 4, right? And then the additional toppings, right? So if you want something other than just cheese, right, you're going to pay $1.50 on a small pizza and $2 on a large pizza or a large pie, right? So we're looking at these two equations, okay? Y equals 1.5x plus 8 and y equals 2x plus 12, okay? We see that there's a graph over here with two different colors, right? We see an A graph that's blue and a B graph that's pink. So now let's go to the questions that it's going to ask. Which equation and which line model the price of a small pizza? Which equation and which line model the price of a large pizza? Okay, again, Philip, in this equation, or in these equations, right? What does the 1.5 and the 2 represent? Slope and rate of change. Good. Rihanna, what does the 8 and the 12 represent in this problem? It has been raining here the last few days, and so the internet is even worse than it has been, so they really can't talk. Good. The y-intercept. Yes, Jordan, go ahead. Y-intercept and what else? The initial value. Very good. So we know the parts of this equation and how they refer to a linear function. So first off, if we look at the graph, are these linear functions? Are they linear functions? I see Rihanna shaking her head. How can you tell that they are linear functions? The line is straight. Good, Melanie. Thanks for helping her out. I think she was getting there. Right? Rihanna, is that what you were going to say? Yeah. So, right. They're straight lines, right? The rate of change is the same the entire way. Forever, as this arrow indicates. So, what I'm going to have you do now is whenever you look at A and B, what is the one thing that you notice that correlates with the equations to the left? What are some similarities that you notice about the graphs, about these two arrows, that you can associate with the equations to the left? I'll give you guys 1 minute. Okay, go ahead and look at both the equations and the graph, and then let me know some of the things that correlate, okay? So for this problem, the y-intercepts are 8 and 12. And if you look at the graphs, they start at 8 and 12, right? So the learners should be able to notice that, okay, line A, right, is for the large pizza, right? Because it costs $12. Line B is the small pizza because it starts at $8, right? Also, the initial value is $8, which correlates. Okay, so who can tell me some similarities between what you see on the graph and the equations to the left? Just go ahead and fire them off in the chat. Go ahead and fire them off in the chat. What do you see? They are both linear equations. Okay, good. Ah, Rihanna, very good. On the y-axis, a number is 12, and a large pizza costs $12. Okay? Good. So, if we know that a large pizza costs $12, which equation or which line goes with the large pizza? Which line, A or B, goes with the large pizza? A, very good. Very good. And why? Let's go ahead and look. Why? Because 12, if you look at it in the equation, is what? If you look at the graph, it's what? The what? The price. Okay, so it's the initial cost, the initial value. And what else? Where do we see it cross the y-axis? At 12. So what does that make it? The y what? The y-intercept. There you go, Philip. You were right. Be more confident, right? It was the y-intercept. So, go ahead and tell me now in the chat which line goes with, or which equation goes with A and which equation goes with B. Okay, just tell me, the first equation's 1, the second equation is 2. Okay, so which one does 1 go with? Does it go with A or B? 1.5x plus 8, does that go with A or B? Good, it goes with B, right? It goes with B. So that means that 2 would have to go with A, right? 2 would have to go with A. Okay. Very good. Very good. I think we're getting the hang of it, right? We're getting the hang of it. We're doing a very good job. Gabriel, go ahead and go into a breakout room. All right. So there you go. For the next problem, I am going to type a problem into the chat. Okay. What I want you to do is you are going to write it on your whiteboard. Okay. You're going to write the equation. Or I'm going to write the word problem. You are going to write in the equation that goes with it. Okay. And then you're going to label it. Okay. How did you know that this is supposed to go there? Right? Because it's the initial value. Because it's the y-intercept, right? You're going to label it after you write the equation. Okay. So let me go ahead and type this in. Give me 1 second. Let me put this down. All right, so there is the word problem in the chat. Go ahead and write that into an equation, a linear equation that follows y equals mx plus b, and then label the parts of the equation for me, please. Don't hold up your whiteboards until I tell you to, okay? Give me a thumbs up whenever you have it. You have it labeled too, Philip? Am I going to be able to read it? Just kidding. Just giving you a hard time, Philip. Thank you, Melanie. Thank you, Rihanna. All right, you can put your thumb down, Philip. I got you. Give you about 15 more seconds, Jordan. All right. Go ahead and hold up your whiteboards. Go and hold up your whiteboards. Make sure you distinguish the difference between 35 and 35 cents, right? Difference between 35 and 35 cents. Good. I see slope and rate of change. I see y-intercept and initial value. Okay. What we got, Jordan? Good. 35x plus 35, right? Good. Okay, go ahead and put your whiteboards down. Go ahead and erase them. Go ahead and erase them, right? So you were able to tell. What was the initial value? The initial value was 35, right? You guys told me. Because no matter what, even if you drove half a mile, you were still going to pay $35 no matter what. No matter what. That was the initial value. Okay? Very good. So what I would like you to do now is go ahead and go back to your Jamboard. Go ahead and go back to, let's go to the main page. Let's go to the main page. Right, we'll go here. So you're still 1, 2, 3, and 4. Whenever I give my whole group lessons, each learner has a number so they know which sticky is theirs to fill out. For this, I just made them 1, 2, 3, and 4 in small group, so it doesn't get all confused and they're all on different slides and things like that. Okay, and on your sticky note, okay, on your sticky note, I want you to tell me, okay, how does the slope and rate of change compare to each other in a linear function? How does the slope and rate of change compare to each other in a linear function? So let's see, I can stop sharing here. I can see their screen if I go here. Good. So I see Philip, the slope and rate of change are the same thing. They both are m. Very good. That is correct. They both are m. Good. I'm seeing some very good answers. Melanie, how does slope and rate of change compare to one another? Good, Jordan. Right? Rihanna, very good. They are both m. Correct answers. Very good. Right? So slope and rate of change are the same thing. So if we are in a word problem and we see them referring to a slice of pizza, right, that is $12, right, we know that that's the initial value. Okay, if it's the initial value, it also has to be what? Philip, if it's the initial value, what else does it have to be? Y-intercept, very good, right? So in word problems, right, we don't need to be scared of them. There might be some bigger words, right? The academic language may be a little bit different, but if we're able to identify those 4 parts of that equation, we'll be able to solve it no matter what, because we know what those 4 parts represent and how to put them into the equation, right? So, very good job today, right? This was a great small group session. Thank you for joining us. And we'll go ahead and move on into literature circles right now. So thanks.